Welcome to the deep dive. So if 2024 was the year we all watched the big proprietary giants build these, massive models,
Yeah.
then 2025 was the year the open source community just completely changed the game.
It really was. They didn't just catch up.
No, not at all. We saw open weight LLMs go from being these sort of fast followers, useful but always a step behind, to genuine frontier setters.
And that shift has huge implications for anyone, any company, thinking about how they use AI.
It's arguably the biggest story in tech this year.
I think so. And when we went through the sources, the research papers, the industry reports, the big announcements from DeepSeek, Mistral, Meta, the story is just crystal clear.
Right.
We've basically synthesized it all down to three huge paradigm shifts, what we're calling the big three.
Okay, so what's the mission for this deep dive? What's the one thread we really need to pull for you?
The mission is to unpack these three trends because they're all connected. First, there's what we call the reasoning revolution. It's about how models learn complex, verifiable logic. Second, native multimodality. It just became the baseline standard. And third, and this is the big one, the cost and efficiency imperative. It just shattered the financial barrier to entry.
That last point on cost, I think that's the key. That's the thing you need to get your head around right away.
It is.
Because it completely challenges that old story. The idea that you needed a nation-state's budget to build state-of-the-art AI.
Exactly. The sources show that the actual weights of a frontier model, they're rapidly becoming a commodity. And that is, or should be, terrifying news for the closed-source giants.
All right, let's start with that first one then, the reasoning revolution. You said DeepSeek R1 kicked this off. How?
Well, it fundamentally changed how models are trained after that initial, massive pre-training phase.
So it's not just about throwing more text at it.
Not at all. It was about teaching it to think in a structured, almost auditable way. Historically, you'd use something like RLHF, reinforcement learning, with human feedback.
Right, where a human basically gives a thumbs up or thumbs down.
Exactly. And the problem is that's super expensive and it's subjective. The human rewards an answer that sounds good, even if the logic underneath is, well, flawed. You're teaching the model good manners, not good reasoning.
So the model gets really good at sounding correct rather than being correct. And that's a massive liability.
A huge one. So DeepSeek R1 introduced an upgrade. It's called reinforcement learning with verifiable rewards, or RLVR.
RLVR. Okay, so what's the verifiable part?
That's the core of it. Instead of a human judging the final output, the system uses an external tool like a code interpreter, a math solver, a logic checker to analyze the model's intermediate steps, its chain of thought.
Ah, so it's not the final answer that gets the reward, it's the process, the audit trail. The system is literally checking the model's homework.
Precisely. It allows for this incredibly structured, data-driven reasoning. The model gets penalized for taking an illogical path, and this whole process is managed by an algorithm called GRPO, Generalized Reward Policy Optimization. Think of it as the engine that just efficiently absorbs all those signals from the verifiers. The DeepSeek team trained it on, I think, 600,000 high-quality examples of reasoning.
Wow.
Yeah, long chains of thought, multi-step math problems. It learned what reliable logic actually looks like.
Okay, so if I'm a consultant, the first word that pops into my head is trust.
You are spot on. From that perspective, RLVR is a game changer. It means you can actually teach a model the specific auditable reasoning paths your industry requires.
Which is a must-have for regulated sectors.
Absolutely. Imagine a legal AI that has to cite specific precedents, or a medical AI that has to justify a diagnosis based on clinical guidelines. You can't have fuzzy reasoning when the stakes are that high. This verifiable path is the new foundation.
And that need for efficiency in reasoning, it ties directly into the next big trend, doesn't it? The cost.
It's the perfect link. The technical superiority we just discussed connects directly to shattering that financial barrier.
So let's talk dollars.
Okay, the cost disruption from DeepSeek V3 is probably the most shocking number in all the source material we looked at. The estimated training cost for that model was only $5 million.
$5 million. Just to put that in perspective, 18 months before that, a top-tier model training run was estimated at what, over $100 million?
Well over. We're talking about the difference between a Series A funding round and the GDP of a small country. It's a fundamental shift.
It just completely reframes the entire conversation.
It does. It proved that state-of-the-art model weights are becoming a commodity. The barrier to entry just collapsed from hundreds of millions down to the single-digit millions.
And that wasn't just about, finding a few shortcuts. It was a whole architectural revolution.
Exactly. A decisive shift away from those monolithic, dense models.
Okay, so explain that. We've all heard the term mixture of experts, or MOE, but why did it suddenly become the standard that made this possible?
Well, think of a traditional dense model, like one giant brain. Every single thought, every query has to pass through every single neuron. It's powerful, but it's incredibly wasteful.
Right.
And MOE model is more like a council of highly specialized experts. When you ask a question about, say, calculus, the query only gets routed to the one or two math experts in the model. The rest of the network stays dark.
So you're not lighting up the whole brain for every single thought. You're saving a massive amount of energy and time, especially during inference.
Precisely. The whole goal shifted to optimizing for performance per watt. And when Mistral adopted the DeepSeek V3 architecture for their flagship Mistral 3 model, that was huge validation for the industry.
Right, it proved that this efficient sparse design could outperform brute force scaling.
The race was no longer about total parameter count. It became about minimizing the active parameter count.
The sources also mentioned something called gated delta nets in Qwen 3 Next. What's that about?
That's another novel attention mechanism. It's all about the internal wiring. Gated delta nets are designed to be extremely selective about which connections to activate for any given task. It's another step in cutting down the energy cost for every single query.
So if you're an investor or CEO looking at this landscape, what does this all mean? If the foundation models are now cheap to make, where does the value go?
That's the critical strategic question now. The focus has shifted entirely up the stack to the implementation layer, meaning value is captured by people who own one of three things. First, the proprietary data you use to specialize these models. Second, the application you build on top of them. And third, the specialized infrastructure to run them. The investment has moved above the foundation model itself.
Okay, which brings us to the next big trend of the year.
Yeah.
Llama 4. Meta really came out swinging with that one.
They did. They adopted the MOE architecture and basically set the new definitive standard for what an open-weight flagship model has to do.
And the first thing was native multimodality.
It became the non-negotiable baseline. We're past the era of, trying to glue a text model to a separate vision model. Llama 4 established that seamless native handling of text, image, and audio, all fused together, is the standard. If your new model only does text, you're already behind.
And being Meta's first MOE model, it had a pretty clever architecture, right? With the routed and shared experts.
It did. It has routed experts, which are the specialists we talked about, but it also includes a crucial shared expert that handles all the common general knowledge tasks. This hybrid approach is really efficient.
And speaking of efficient, they really focused on accessibility.
That was the masterstroke. Llama 4 was explicitly optimized for efficient inference on a single H100 GPU.
A single H100, so you don't need a massive data center anymore.
Exactly. It means frontier-level intelligence is now accessible to a much, much broader range of companies.
And then there was the Scout model.
Yeah.
Enormous context window. 10 million tokens.
10 million.
Yeah.
And that is a moment where enterprise AI strategy just fundamentally simplifies.
Explain that. Why is that so important?
Well, to get it, you have to remember the old way of doing things, which was retrieval augmented generation, or RAG.
RJ. Notoriously complex.
Exactly. RAG meant chopping up all your documents, indexing them, and then building this complex, brittle pipeline to go find the right snippets to feed the model. It required constant maintenance.
And now?
Now, with a 10 million token window, clients are just moving to whole document reasoning.
So instead of all that complexity, you just feed the model the entire 100-page compliance manual or the full patient history in Run Go.
That's the idea. You just fire hose the whole thing into the context window and ask the model to reason across it natively. It's simpler, you get rid of all that technical debt, and the accuracy improves because the model sees everything at once.
That makes perfect sense.
So to kind of synthesize all these architectural shifts, from DeepSeek's GLPO to Llama 4's massive context, the focus for engineers is now entirely on inference efficiency. They are obsessively monitoring active parameter counts and optimizing for that single GPU performance.
And that technical efficiency feeds right into what the biggest customers need. Why did models like Llama 4 and Mistral 3 become the default choice for finance, healthcare, government?
One phrase. Data sovereignty.
Right.
It's the ultimate requirement. These companies must maintain absolute control over their proprietary data to meet regulations. Open-weight models let them deploy on-premise behind their own firewall.
You can't do that if you're sending your most sensitive data out to a third-party API.
You simply cannot. So the technology finally enabled them to meet their most critical business and regulatory need. It was a perfect storm.
Okay, but here's a question. If everything is so much more efficient, training costs are down, they run on single GPUs, why does the source material say that demand for high-end compute for H100s and B200s is still through the roof?
That's a great question. It comes down to volume, pure and simple.
Ah,
While the cost per model has plummeted, the sheer number of models and variants being trained is unprecedented. And more importantly, you're seeing this massive explosion in enterprise-specific fine-tuning.
so everyone is taking these base models and customizing them.
Everyone. They're taking the $5 million open weight model and pouring their own proprietary data into it to create a custom legal model, a custom drug discovery model. Every vertical is building and testing, and all that activity drives this huge continued demand for the hardware.
Okay, so let's summarize this deep dive on 2025. It was really the year of convergence.
Absolutely. Hardware efficiency met this massive demand for sovereign, auditable AI.
Right. We had DeepSeek R1 bringing us RLVR for superior reasoning. We had the DeepSeek V3 architecture slashing training costs down to $5 million. And then Llama 4 set the new baseline with native multimodality and a 10 million token context window.
It really defined a new, far more accessible era of AI deployment. That's the perfect wrap-up for 2025.
So what's next? If that was 2025, what's the prediction for 2026?
I think if you connect all these dots, the outlook for 2026 gets really interesting. While 2025 was about cost disruption and setting new standards, the prediction for 2026 is that the entire race is going to shift again.
Away from scale.
Away from just absolute scale, yes. The race will be about achieving the absolute best performance per dollar spent.
The efficiency metric.
Exactly. A relentless pursuit of efficiency, all aimed at one thing: delivering models with near-human deductive reasoning capabilities. It's not about being bigger anymore. It's about providing that verifiable, complex logic running economically enough to be deployed everywhere.
That level of verifiable economic intelligence.
That's the next frontier, and that is something for you to mull on.
A fantastic deep dive. Thank you for joining us.